Hello. So I'm here to tell you that what you have believed about your own potential has changed what you have learned and continues to do that, continues to change your learning and your experiences. So how many people here, let's get a show of hands, have ever been given the idea that they're not a math person or that they can't go on to the next level of math, they haven't got the brains for it? Let's see a show of hands. So quite a few of us. And I'm here to tell you that idea is completely wrong. It is disproven by the brain science, but it is fueled by a single myth that's out there in our society that's very strong and very dangerous. And the myth is that there's such a thing as a math brain, that you're born with one or you're not. We don't believe this about other subjects. We don't think we're born with a history brain or a physics brain. We think you have to learn those. But with math, students believe it, teachers believe it, parents believe it. And until we change that single myth, we will continue to have widespread underachievement in this country. Carol Dweck's research on mindset has shown us that if you believe in your unlimited potential, you will achieve at higher levels in maths and in life. And an incredible study on mistakes showed this very strongly. So Jason Moser and his colleagues actually found from MRI scans that your brain grows when you make a mistake in maths. Fantastic. When you make a mistake, synapses fire in the brain. And in fact, in their MRI scans, they found that when people made a mistake, synapses fired. When they got work correct, less synapses fired. So making mistakes is really good. And we want students to know this, but they found something else that was pretty incredible. This image shows you the voltage maps of people's brains, and what you can see here is that people with a growth mindset who believed that they had unlimited potential, they could learn anything, when they made a mistake, their brains grew more than the people who didn't believe that they could learn anything. So this shows us something that brain scientists have known for a long time, that our cognition and what we learn is linked to our beliefs and to our feelings. And this is important for all of us, not just kids in math classrooms. If you go into a difficult situation or a challenging situation and you think to yourself, I can do this, I'm going to do it, and you mess up or fail, your brain will grow and more and react differently than if you go into that situation thinking, I don't think I can do this. So this is really interesting. When we calculate, even when adults calculate, where a brain area that sees fingers is lighting up. We're not using fingers, but that brain area that sees fingers lights up. So there's a brain area when we use fingers, and there's a brain area when we see fingers. And it turns out that seeing fingers is really important for the brain. And in fact, finger perception is, scientists test for finger perception by asking people to put their hands under a table, they can't see them, touching a finger, and then seeing if you know which finger has been touched. The amount that university students have good finger perception predicts their calculation scores. And the amount of finger perception grade 1 students have is a better prediction of maths achievement in grade 2 than test scores. It is that important. But what happens in schools and classrooms? Students are told they're not allowed to use their fingers. They're told it's babyish. They're made to feel bad about it. When we stop children learning number through fingers, it's akin to halting their numerical development. And scientists have known this for a long time. And the neuroscientists conclude that fingers should be used for students learning number and arithmetic. If we hadn't published this, we published this in a paper in The Atlantic last week. I don't know any educator who knew this. This is causing a huge ripple through the education community.